Today we're going to look at a very different type of puzzle. We call these motion puzzles, and when we work with motion puzzles they can follow one of several formats. Typically what we're looking for is how long it takes two vehicles to meet up in the middle or to pass each other or to be a certain distance apart. Here are the different types of problems you might encounter. First of all, you might have two different vehicles that start at the same spot, but one leaves later than the other. The second one, we might have two vehicles that start at the same location but travel in opposite directions. Another possibility, two vehicles that start at different spots and travel toward one another. Finally, we may have a situation where a vehicle leaves home, goes somewhere, and then comes back. In our first video, we're going to look at the first type of problem, where two vehicles start at the same spot and head in the same direction. Now there's a couple of things we need to know before we get started. Let's take a look at that. First thing you should know, and you probably remember this from science class, distance equals rate times time. Okay, so how far a vehicle goes, you take the number of miles per hour times however many hours it travels for, and that gives you the total distance. When you're setting up your table to organize your information, this is what it'll look like. We have distance, rate, and time. So rate times the time traveled equals the distance. And notice over here I have my first vehicle and my second vehicle. Now the vehicle could be a car, a train, a bus, an airplane, it could be people running. So when I say vehicle, I kind of encompass a lot of different things there. Now this is what our table looks like, and here's what you need to know. Often they will say, when will vehicle 1 catch up to vehicle 2? So suppose we have one vehicle that leaves at 1 o'clock, another one that leaves at 2 o'clock. The first one has an hour head start. We want to know when the second one can catch up to it. And so that's what we're looking for. Now keep in mind this. If this car has traveled 50 miles, this one catches up when it has also traveled 50 miles. So they've traveled the same amount of distance. So another car catches up to the first or overtakes the first when they've traveled the same amount of distance. And that's going to be very helpful as we work through these problems. In our first example, we have two different trucks. The first one leaves at 3 o'clock and the second one leaves an hour later. The first truck is going a little bit slower, it's going 45 miles per hour. The second one is going 60 miles per hour. So the second one's going quite a bit faster. Now, I recommend drawing a picture. Okay? So here we go. At 3 o'clock, the truck leaves and it's heading on the road 45 miles per hour. We don't know how long it traveled, so we just say it traveled for X hours because we don't really know. Then, an hour later, the car takes off. It's going 60 miles per hour. Now, we don't know how long it traveled either, but it did travel one less hour than the truck because it left an hour later. So it traveled an hour less, which means it traveled for X minus 1 hours. Now we can use that information to fill out the table. So we have the truck, 45 miles per hour, X hours, so the distance it travels is 45 times X. The car, on the other hand, went 60 miles per hour, and it traveled for X minus 1 hours, so the distance it covers is 60 times X minus 1. Now, because we want to know when the car will catch up to the truck, well, here's the truck. When the car catches up, they've traveled exactly the same distance. Therefore, this distance will equal this distance. And so we say 45x equals 60 times x minus 1. That means that x equals 4. So the question is, how long does it take the car to catch up? Well, the car traveled x minus 1 hours, so 4 minus 1, 3. It takes the car 3 hours from when it leaves home to catch up with the truck. There's a lot to these problems, a lot of information to organize through. Best thing to do, draw a picture so you can understand the problem. You should have up here the rate, or the speed the thing is traveling, and the number of hours that it traveled. Here they gave you the speeds, so we called one x, and the one that left later, x minus 1. Filled it into the table. We knew that because the car was catching up, they were going the same distance, and so we wrote our equation, solved it, and then answered the question. And of course, you should always ask yourself, does the answer make sense? If you came out with, for example, 700 hours, that's not quite right. That just doesn't make sense. So always ask yourself, does my answer make sense? Another example, example 2, is right here. Now we're going with airplanes. We have a cargo plane that leaves at noon, and it's traveling at a rate of 400 miles per hour. Here's the airplane. So cargo plane left at noon, 400 miles per hour. The passenger plane left 2 hours later at 2 o'clock. It went 560 miles per hour, and they were traveling in the same direction. Now, the question is, how many miles do they travel before the passenger plane overtakes or passes the cargo plane? Well, here's our passenger plane, left at 2 o'clock, going 560 miles per hour. We don't know how long they were in the sky, so we say the cargo plane was in the sky for X hours, and the passenger plane, which left later, X minus 2. Now we want to find out some information here. So we set it up in our table. We have the cargo plane, the passenger plane, rate, time, and distance. So we have our rate of speed in there, the amount of time from our drawing, and the distance, 400 times x, rate times time, and the distance over here, rate times time, 560 times x minus 2. Now, when does the first one pass it? Well, it passes it when they've gone the same distance. So this distance here must be equal to this distance here. So 400x equals 560 times x minus 2. We solve that equation, we find out that x equals 7. Now be sure to answer the question. The question was not how many hours, although this is number of hours. The question was how many miles, how far, what was the distance? Well, let's see. Let's plug into it. When does the passenger plane catch up? Well, when it's gone this many miles, 560 times x minus 2. So I take that 560 times x minus 2, I plug in the 7, and I find out that it's 1,680. By the way, if you plug that 7 into the first one, you will come up with a very similar result. And so this is how you go about solving problems that involve motion when two objects start at the same place and are heading in the same direction.